So again, we are now on the introduction to organic chemistry. The book that we use here is the General Organic and Biochemistry 9th edition by Deniston K. et al. So for our learning objectives in this lesson, you are expected to first differentiate what organic and inorganic compounds are. Okay, Kim. And then identify the different functional groups. Apply the basic rules of the IUPAC in naming organic compounds. So just like the inorganic chemistry, we will also learn how do we name our organic compounds. So the rules are different, syempre. And then aside from that, we will also learn to draw the structures that represents alkanes and cycloalkanes. So we will concentrate first with the alkanes and the cycloalkanes before moving on to the different functional groups or to other functional groups. So let's start. So when you say organic chemistry class, this is a branch of chemistry that deals with the study of carbon and the carbon-containing compounds. So do not forget that. When you say organic chemistry, we are dealing with carbons and all the compounds that contain carbon. Now, this is very important for the study of biochemistry because when you say living organisms, including us, syempre, we are actually composed, our primary components or primary constituents are made up of carbon. So mga carbon-containing substances yan sila. Therefore, without carbon and those carbon-containing compounds, wala ding life. So we have here examples. These are only examples of organic compounds with their common names. So this is not yet the systematic name or the IUPAC name, but these are the common names of our common also na organic compound. So we have the first one, the ethylene. This is the chemical structure of the ethylene. As you can see, you have there two carbons connected by double bond. So ethylene class is used as a gas for to aid fruit ripening. So if you hear or if you have heard the word galburo, yan yon. One of the chemical that is used for that is the ethylene. It's carbon containing, so it's organic compound. And then we have acetylene also. The difference of ethylene and acetylene is that ito, dalawang, a similarity is dalawang carbon pa rin, but the difference is the two carbons are connected by a triple bond. Okay? And then we have the benzene here, which is made up of 6 carbons, which is formed as a ring. The same thing with toluene and xylene. Meron lang silang mga branches. And then, by the way, these 3 are actually used as solvents in the laboratory. And then we have formaldehyde, and then diluted na solution of formaldehyde, mga at least 37% is what you call the formalin, which we use as an embalming fluid to preserve tissues and bodies, living, what do you mean that? What do you call that? Mga cadaver. Ayan, formaldehyde is an organic compound. So when you say again when you hear the word, it is an organic substance or organic compound. In chemistry, these are substances which contain carbon in their chemical formula or in their chemical structure. And then we also have the formic acid. By the way, formic acid is a substance being released by insects just like ants and even the bees. And this will be responsible in the itching and pain that we feel if ever masting tayo or makagat tayo ng either ant or bees. Formic acid yan. They have the ability to produce this organic substance. Now, aside from that, formic acid is actually the metabolism product of methanol. So, di ba, meron tayong mga alcoholic drinks in the market. So, I hope you are not into it kasi when you say alcohol, we don't really have a good effect of that in the body. So just like personally ako, I don't drink that. But yung iniinom na alcohol class is what you call the ethanol. That is the IUPAC name. But when you say the common name, we call it ethyl alcohol. So the alcohol that is being consumed by the drinkers and the alcohol that we use as disinfectant, like yung mga Green Cross, aside from the isopropyl alcohol, it's actually the same, the ethanol or the ethyl alcohol. But syempre, I'm not saying na you can drink those that are used as disinfectant kasi it is not processed to be consumed. So aside from that, we have the so-called methanol. This is another type of alcohol, but this should not be consumed because this one is considered as toxic and this can also cause blindness. And I don't know if you have heard the news dati in the past that there were cases of lambanog poisoning, or sa Bisaya pa we call that tuba. 'Di ba na yung mga poison dati sa tuba. Some of them survived but they had a lot of signs and symptoms including sakit ilahang tiyan, and some were even vomiting. There is nausea and vomiting. But yung iba hindi talaga nakasurvive, na namatay talaga sila after drinking the lambanog. What's the problem of that? When I read that news, the lambanog was actually contaminated with methanol. So I don't know though if that was deliberately added to the drink or that was added accidentally. But again, the identification of the content of the solution showed that there was the presence of methanol. Now, inside the body kasi methanol will be converted into formaldehyde. Imagine formaldehyde in the body. This will become formaldehyde. Na-mention ko kanina, formaldehyde, the diluted solution of that is called the formalin. And then further degradation of formaldehyde in the body will give us formic acid. So ito yon, formic acid. Pag mag-metabolize ha, remember, all that we eat, all that we consume, dinadigest natin and nag-undergo ng metabolism. And when it undergoes metabolism, it will result to a new substance. So in the case of methanol, it will become formaldehyde and then it will become formic acid. Now, formic acid is actually a substance that can cause blindness when consumed. Okay lang if you are stung by a bees or an ant, kasi you will just have the pain and the itching. But if you really consumed a lot of formic acid, it will cause blindness. So, isang sign, isang symptom na na-feel ng mga na-poison sa lambanog drink is actually lumabo yung kanilang paningin. So, yun na digest na metabolize na si methanol and they have already a lot of formic acid inside. Okay? But these are just examples of organic compounds. And then we have phenol, which is used as a disinfectant also. Actually, this is our gold standard for our disinfectants, the phenol. And actually the Lysol, though Lysol is just a brand, but it contains a derivative of phenol. And then we also have aniline, and styrene, which can also be used as solvents in the laboratory. And we have here the acetaldehyde. So acetaldehyde naman is the degradation product of ethanol in the body. Okay, again, acetaldehyde is the metabolism or degradation product of ethanol in the body, and actually this substance causes the hangover. So I think you are familiar with this, those who are drunk after after drinking, they will have the hangover. So they will have headache and sa pa na ilang na feel. I'm not really that familiar with hangover kaya wala ko nagainom og alcohol, but nevertheless it's due to acetaldehyde. Even the even yung mamula gani kasi nakatry mahubog dire. Ang kanang mahubog na mamula, even if wala pa sila nahubog pero namula na sila, it's due to acetaldehyde pa rin. A lot of this inside the body can again cause hangover and redness. Okay, wait lang ha, wait lang. Wait lang class ha, kay naitaw. Okay, sorry for the interruption. Asa na ta? Acetaldehyde na tano. And then, further degradation of acetaldehyde will have the acetic acid. So that's the next example of the organic compounds natin. Acetaldehyde, but you cannot really see this acetic acid in the body. It will be transformed. The acetaldehyde will be transformed into acetic acid in the urine But nevertheless, ano siya, product of metabolism. And then aside from that, what you need to remember is that acetic acid is the acid that can be found in vinegar. Okay, and then acetone also, I believe you are familiar with this also. So girls, we use this one, not just girls, no, but there are also other men who have kanang nail polish, but nevertheless acetone is used as commonly as nail polish remover. Again, nail polish remover siya. Excuse sa class ha, 2 minutes. Sama kayo. Okay. Let us continue. Next, we have the benzaldehyde and the benzoic acid, which are used as most of the time preservatives in food or in our pharmaceutical products, mga drugs na to, ginagamit sila to preserve and to avoid contamination, microbial contamination. So again, these are examples of organic compounds and some of their uses. However, as we go on with our lesson, I'll be teaching you how to name them and how to draw their structures also. Now, let's talk first about carbon. So we have here, ayan, carbon. If you look at your periodic table, carbon belongs to the group 4. And that means na meron siyang 4 valence electron. So remember, when we defined what valence electrons are, valence electrons are those electrons that are found in the outermost shell. Remember, meron tayong shells, mga orbitals, orbiting the nucleus of the atom, and that is where we can find our electrons. So yung pinakalabas na shell, doon natin makikita si valence electron. So for carbon, we have again 4 valence electrons, and these valence electrons can actually form bonds either with kapwa niya carbon or with other elements. So again, these electrons can form bonds to other elements or to other carbon. So kaya ni carbon plus mag-bind sa kanyang kapwa carbon. So meron tayong carbon to carbon bonds, and we call this ability as catenation. If you hear this word catenation, it means it is the ability of carbon to bind with itself, meaning carbon to carbon bond. And by the way, the bond is called covalent bond, which is a strong bond. So covalent bond takes place between a non-metal and another non-metal. Remember, carbon is a non-metal. So if it binds with another non-metal, the bonding is called covalent bond. However, in organic chemistry, di ba we have metal plus non-metal. If they bond together, the bond is called ionic bond. So let's just differentiate. If it's metal and non-metal, we call it ionic bond. Okay? So when you say covalent bond, again, it's between non-metals, and actually the difference between, differentiate na lang natin, no, ionic, and you have here the covalent, or we call this, other name for covalent bond is molecular bond. Molecular bond. So si ionic, it's between non-metal and a metal. Baliktad. Nauna si metal, class. Nauna si metal. It's between metal plus non-metal. And this involves transfer of electron. Again, this involves transfer of electron. While this one, the other one, it's non-metal plus non-metal, and this involves sharing of electron. Again, this involves sharing of electron. That is their difference, but both of them are actually strong bonds. Nagsaba na sa dang among iro, which means na ano sa tao tabang mga langit. Okay, I hope nakuha yon. Wait lang ha. Okay. So let us continue. Now let's have the characteristics of the organic compounds. So the first thing that you need to remember is that organic compounds are non-polar. Therefore, they do not dissolve and they do not mix with polar solvents like water. So water is considered a polar substance while the organic compounds are non-polar. So hindi yan siya madidissolve or hindi yan sila magmimix. So just like water and oil, because remember, we have the rule in chemistry na like dissolve, likes dissolve, likes. Okay? Polar plus polar and non-polar plus non-polar. Now, what is the difference now between a polar and a non-polar substance? So pag polar class, ang inyong tandaan, there is an equal sharing or distribution of electrons. Unequal yung sharing or yung distribution of the electron, just like the water. Remember, pag sinabing organic substances, there is covalent bonding involved, and then there is sharing of electrons. Hindi siya nagta-transfer unlike the ionic bonding. Instead, nag-share sila ng electron. But the sharing for polar substances are unequal. So just like sa water. Not just the sharing, but the distribution. Now, for non-polar substances, there is equal sharing or pwede ding equal sharing or distribution. The same thing of the electrons. That's the difference between a polar and a non-polar substance. So in the case of water, kasi you have oxygen at the center and then you have hydrogen, diba? Bonded together to oxygen. And then remember, class, that hydrogen has one valence electron. Nasa alin siya? Di ba nasa group 1. So meron siyang one valence electron. While si oxygen naman nasa group 6. So ang mangyayari kay oxygen, meron siyang 4 na free electrons. And then yung dalawa, i-share niya sa oxygen. Isa para sa isang hydrogen, I mean. And then another one will be shared to hydrogen. So, ang mangyayari niyan, we will have dipole moments here. Hydrogen will become partially positive because of the sharing. And then, another hydrogen here will become partially positive. However, since oxygen has a 4, meron siyang 4 na free electrons, this will be considered as partial negative na part of the molecule. So as you can see, hindi equal yung distribution. Not the sharing ha, I'm not talking about the sharing though, but actually pwede sad siya sa sharing kasi oxygen will share 2 while hydrogen will just share 1. But nevertheless, the distribution will not be equal. That is why water is considered a polar substance. However, for organic substances, for example, we have the carbon tetrachloride. Again, carbon tetrachloride, meron tayong carbon dito. So si carbon, remember, meron siyang 4 na valence electron. And then, meron tayong 4 din na chlorine, which means isang chlorine dito. Isang chlorine sa bawat sides. And then chlorine is a member of group 7 in the periodic table, which means meron siyang 7 valence electrons. So 1, 2, 3, 4, 5, 6, and then 7. The other one will be shared to carbon. And then that is also true class ha for the remaining chlorine. Okay? Again, the remaining chlorine. Now, since the sharing is done by carbon, the carbon will become partially positive for the dipole. Kasi ubos, di ba? Ubos lahat ng kanyang electron. Na-share niya lahat. So, magiging, kung molecule siya, that part will become partially positive. However, lahat ng chlorine, meron silang mga extrang electrons dyan, partial negative silang lahat. Wait lang, partial negative. Now, yung dipole moment kasi na tinatawag for our molecules, ang kanyang movement is going to the negative side na part of the molecule. So if this is the positive na part, the movement is going there. And then the other one, the movement also, the dipole, meaning the movement of the electron is also going here sa another chlorine. That is also true for this chlorine. And that is also true for this chlorine. Now, since they can cancel each other, kasi parehas silang going on the exact na side, maka-cancel yung pag-move ng electron, mag-i-end up siya sa equal distribution. So this is the reason why carbon tetrachloride is considered a non-polar substance. This one naman is polar. So the distribution lang siya, yung dipole moment kung saan papunta si electron. Okay? Lang, ha? Any question? Nevertheless, you have to take note, class, na ang ating mga organic compounds are non-polar and that water is polar, so they don't really mix together. Okay? Questions? Nga naman na every hindi ako mahuman ko sa akong slide na ay tao. Wait lang kasi. Okay. Ay, nga naman. Sige, pagputol-putol. Anyway, ma'am, paano po ulit naging non-polar? Naging non-polar si ganito. Let me get my pen. Si carbon tetrachloride kasi, wait lang ha. Diba si carbon, shinare niya lahat ng kanyang electrons, walang natira. Yung isa, 4 diba ang valence electron niya? Yung isa para sa isang chlorine, yung isa para sa another chlorine, and so on. So walang natira. So kapag kaganon sa ang molecule class, ang tawag sa kanya partially positive. Kagaya ni hydrogen, shared niya lahat ng kanyang electron, partially positive siya. Pero kung may natirang electrons class, magiging partially negative side of the molecule siya, kagaya ni oxygen and kagaya nitong mga chlorine na ito. Now, the dipole moment or the movement para ma-distribute yung electron, because remember, walang transfer na nangyari. Ang nangyari lang, mag-share sila. So, the electrons are still there, pero they are moving kung saan sila dapat papunta. Doon sila mag-move sa negative portion of the molecule. So, since mga chlorine ito yung mga partial negative side of the molecule, dun pupunta yung dipole moment ng ating mga electrons. However, ang nangyari, since pareha sila ng ano tawag dyan? Direction. So like this one, going to the left, going to the right, magka-cancel yung kanilang dipole moment. Hindi na mag-move yung electrons. So mag-i-equal yung sharing on both sides, sa left and sa right. That is also true for this one, going up and going down. Magka-cancel lang din yung kanilang dipole moments. Kasi going up o going down, no, dili na sila, dili na ang electron mo adto sa baba, dili pud ang electron mo adto sa taas. So ang ending ana equal distribution lang of the electron. So that is why carbon tetrachloride is called a non-polar molecule. Hindi siya kagaya nitong water na the movement is going to the ano, 'di ba? Going to the negative portion of the molecule. Take note that the hydrogen is partially positive. So going there, ang movement ng dipole. And then that is also true for the other hydrogen. So walang pagka-cancel yung mangyayari dito. Thus the electron will be, ang dipole natin is nandito na portion ng molecule. That ends up to the unequal distribution of the electrons. That is why water is considered as a polar molecule. Ang ibig sabihin ng polar class, meron siyang poles wherein doon yung moment ng ating mga electrons papunta. So meron siya, nasa gitna. However, si carbon tetrachloride, non-polar siya, walang mga polar sides wherein the electrons will be distributed. That's the difference between polar and non-polar. And then again, do not forget that our organic compounds are non-polar compounds. So they will end up with equal distribution or sharing of the electrons. Sa inorganic kasi wala tayong problema kasi magta-transfer na lang naman, 'di ba? Magdo-donate. Example, the metal will donate the electrons and the non-metals will accept the electrons. So kung ilan yung dinonate ni metal, yun din yung i-accept ni non-metal. However, that is not true for organic compounds because they don't end up transferring and gaining or losing electrons, but they will end up sharing. But the electrons within the molecules will have dipole moments, and yun yung mag-identify whether they are polar or non-polar. But basta ang inyong tandaan, the movement is going to the ang tawag dyan, negatively charged or negative side of the molecule. Yun yung may mga extra na mga electrons that are actually not shared or they are not bonded. Okay? So that's the first characteristic of our organic compounds. Now, the second one, our organic compounds have low melting points, meaning if we subject them even in just low temperature class, magme-melt na sila agad. So this does not require ng taas na jud kay nga temperature para ma-melt. Dali lang nato class ipa-melt ang mga organic compounds. And what is the reason for that? Organic compounds have weak intermolecular forces. So let's have an example. You have one molecule here, carbon to carbon bonding. This is considered the blue one, which is made up of carbon and another carbon bonded together is one molecule. And then you have another molecule here with the same component, carbon to carbon bond pa rin, another molecule here. So magsasama yan sila and they will be attracted with each other. And the attraction or the bonding is called the intermolecular forces. So again, when you say intermolecular forces, it's the bond that is formed between our molecules. Okay, between molecules, between one molecule of this carbon to carbon bonding and another molecule with this carbon to carbon bonding. Now, these intermolecular forces are weak. Therefore, if we subject it to even just a low temperature, this will be easily broken. Kaya magme-melt kaagad, magbabago yung state ng matter ng ating compound. So again, this is a weak force between the molecule. What is strong here is the covalent bond. Remember this bonding between carbon and another carbon? Diba, ang sabi ko kanina, non-metal plus non-metal, the bonding is called covalent bond. So this bond here, is, as you can see, let me change the color of my pen. Ay, lalagyan yung sulat. Wait lang. Okay. So you can see this one. This is what you call the covalent bond. It's between two non-metal atoms. This is also class a covalent bond. This time sila ay strong. Ano ang weak? This one. The bond at the center. Bond joining the molecules together, we call it intermolecular forces. They control how well molecules stick together, and since they are weak, they can easily be broken. That is why we have low melting points for our organic compounds. You can ask question anytime if you are confused about something, if you don't understand something about the lesson. That's the second characteristic of our organic compound. The third one is they react slower compared to our ionic compound. So bakit naman they react slower? Kasi due to the presence of the covalent bonds between the atoms. So yun naman yung effect ngayon of having the covalent bonds. Remember in our inorganic chemistry, if we have the test tube class, and for example, we mix together the silver nitrate and the NaCl, we will immediately see the evidence of the chemical reaction through the formation of the precipitate, the silver chloride. So this one is ionic na compound. However, for organic compounds, if we make them react with each other, they will still react, but the reaction will be slower. Bakit again? Kasi the bonding between these atoms are very strong. Covalent bonds are stronger than the ionic bonds. So mahirap itong i-break. Again, mahirap itong i-break class, then that will result to the slower reaction rate. Remember ito, madaling i-break, di ba? Silver nitrate, i-break natin siya para si silver ma-free, and then sodium chloride, i-break din natin, ma-free yung mga components, and mag-exchange partners sila. Silver will now be with chloride, and sodium will be with the nitrate. That's ionic bonding. I-break natin sila through chemical reaction. But then again, covalent bonds are strong, so the reaction will proceed slowly. That's the difference. And that's the third characteristic of the organic compounds. Questions so far about the characteristics of our organic compounds? Wala. Sige. So let's move on. Let's answer this question. Why do we have so many organic compounds? Mas daghan pa siya compared to our ionic compounds. Remember, ionic compounds are, though we have a lot of metals that can join or that can bond with non-metals, but their number is actually limited. However, pag sinabing organic compounds, daghan kayo taog organic compounds class. And the first reason for that is that carbon can form bond with kapwa niya, carbon. So it's actually a covalent bond. So it's a stable bond between carbon and another carbon. So what is the example of this? The example of this is this one, the presence of allotropes. Sino dito yung may knowledge or may idea what allotropes are? Anyone? Sino dito yung may idea what allotropes are? Wala. Ala, sige. Allotropes class are substances which contain the same component but differ in their physical and chemical properties. Let me give you an example para mas maintindihan what allotropes are. We have the first one here, the diamond. You know what diamond is, right? It's a mineral and it's one of the hardest mineral. Dati, it was the hardest. You cannot actually break a diamond if you don't have another diamond na pwede mong gamitin to break it. That's how hard it is. Kapwa niya lang diamond ang makabreak sa kanya. Pero ngayon, meron na silang na-discover na harder pa than the diamond, which I forgot the name. However, one of the hardest pa rin siya. Now, what are the components or what is the component of diamond? It's actually carbon. A lot of carbon bonded to itself. Daghan na carbon bonded to itself. Okay, naliman na. Okay? Daghan nga carbon. Anyway, all are just carbon for diamond. So as you can see, it is the one of the hardest naturally occurring substance. Now we have another one that is also made up of carbon, a lot of carbons also. We call that the graphite, which is one naman of our softest na mineral. Where can we see graphite? Saan natin makikita ang graphite?
Lead sa pencil na.
Okay, very good. Lead of the pencil. Yung ginagamit natin pang sulat sa lapis. That is actually the graphite, and that is also made up of carbon. However, if we compare the two, diamond is very hard, while graphite is very soft. So they are made up of the same component, but they differ in their physical and chemical property. Silang dalawa are called allotropes of carbon. Okay? Actually, pwede pa nating dagdagan the charcoal. You know that the charcoal is also made up of carbon. So it's one also of the allotropes of carbon. But if we compare it sa diamond and sa graphite, you can easily see and observe that it also has different physical and chemical properties. So that is one of the reasons why we have so many organic compounds. Carbon can form stable covalent bonds with other carbons, okay, even resulting to the existence of our allotropes. Now, what is the second reason? Aside from the ability of carbon to form bonds with itself, carbon can also form stable bonds with other elements. So if the element is also a non-metal, just like nitrogen and sulfur, the resulting bond is a very strong bond, which is also covalent bond. That's number 2 reason. And then number 3 is that carbon can also form double or triple bonds with other carbons, which result to another naman na group of substances with different identity, different physical and chemical properties. So again, hindi lang siya carbon to carbon single bond. The carbon also has the ability to form multiple bonds with another carbon. So pwede siyang double bond and pwede din siyang triple bonds. So iba-iba sila ng identity. Okay. Questions so far? Kasi nabot pa ta sa atong mga carbons. Or na-confused na before to mag-start with the families of organic compounds? Wala. Wala. Okay, so let's continue. Let's start with the first family of the organic compounds. We have the hydrocarbons. From the name itself, hydrocarbons, these substances, these chemical compounds only contain hydrogen and carbon. Ano lang, hydrogen and carbon lang talaga ang content nila. Okay, that's hydrocarbons. Now we have types of hydrocarbons. The first one is called substituted hydrocarbon. Wait lang, substituted hydrocarbon. Supposedly kasi, di ba, carbon, meron siyang 4 na valence electrons. And then hydrocarbon man. So this one, these 4 are all bonded to hydrogen. Pero if one or more hydrogen atoms is being replaced by another atom or group of atoms, we now call it substituted hydrocarbon. So let me give you an example. We have here hydrogen, hydrogen, hydrogen. And this 4th hydrogen here is being substituted with another atom or group of atoms, for example, OH. So we call this, diba, hydroxide. Sa inorganic chemistry, we call it hydroxide. This time we call it hydroxyl group. Okay? Hydroxyl group. So this one now, as you can see, hydrocarbon, ito hydrocarbon, we actually call this the methane. Or diba, the methane gas. Ayan. Diba pag yung mga septic tank natin, yung mga dumi doon, if mag-decompose na sila, they will become gas in the form of methane. Kaya pag sinindihan natin yung septic tank, sasabog talaga. Because again of the presence of the methane gas. So ito lang yung structure ng methane gas natin, carbon and 4 na hydrogen. Pag nag-substitute na tayo, actually, this will not be called totally a hydrocarbon because of the presence of oxygen there, but substituted lang siya kasi you still have the carbon and the hydrogen. This time, we call this the methanol. Yan. So this is again a substituted kasi one of the hydrogen is being substituted by the OH. Yan lang yung difference nila. Kahit anong atom ha, pwedeng carboxyl group, pwede ngang chlorine or other atoms, as long as nag-substitute ka sa one or more hydrogens there, magiging substituted hydrocarbon na siya. Okay? Pwede din yan siyang H. Sulat ko siya ulit. Pwede din naman itong another example niya. We call this the carboxyl group. So magiging CH3COOH na siya. We call this dalawang carbon. So we call this ethanoic acid. Or this is the IUPAC name, but the common name for this is the acetic acid. Kaya sa mong kalibog anak ito doon tang sunod. How to name that and how to identify that. Anyway, ganun lang yung substituted hydrocarbons. Yeah, it's a carboxylic acid. And the carboxylic acids are the organic acids. You will know them. You will identify if the substance is an acid if you have the presence of the COOH. Acid yan siya. Kaya ethanoic acid or commonly called as the acetic acid. Pag meron namang OH, this one is for the alcohol. So just like the methanol or the methyl alcohol. Okay, substituted hydrocarbon. Next, let's have the aliphatic hydrocarbons. So these are all hydrocarbons, hydrogen and carbons, only. However, meron tayong different types of the aliphatic hydrocarbon. Titingnan nyo yan siya, class. If it only contains single bonds, lahat ha, starting from methane, kahit dagdagan mo siya ng another carbon, or maraming carbon ang idagdag mo dyan, as long as they are all bonded with a single bond, we call them alkanes. Again, pag single bond, alkanes. But this one is for straight chain na alkane. Dagdagan mo siya ng carbon kahit aabot ka dyan ng 100 na carbon, but if it is a straight chain, we call it alkane. But if you have class A structure of carbon na single bond pa rin, pero it forms a ring. Again, magfo-form na siya ng ring. Just like this one. Let me draw it sa screen. You have carbon, and then idugtong mo siya with another carbon here, another carbon. And then, nag-form siya ng ring kagaya nito. That is the time we call it cycloalkanes. Okay? So, kaya makakita kayo, class, ng mga organic compounds na ganito yung itsura nila, or even ganito, mga mga shapes natin, class, mga rings ang tawag natin sa kanila. Pag single bond yan lahat, cycloalkanes. Again, cycloalkanes. Now, kapag meron na siyang double bond, example, carbon and another carbon, meron na siyang double bond, class, we now call it alkenes. So again, the double bond will be called alkenes. So kung nag-form ka naman ng ng ring dyan, example this one, dagdagan mo. This is how you know na may double bond na kasali dyan sa ring. O kaya dito siya. Marami siya. Basta may double bond ka, we call that cycloalkenes. We call them ito. Who is that? Shakira man taon. Okay, nakuha to, no? Now how about if you have carbon to carbon triple bonds? If you see this in the structure, we call naman this alkynes. 1, 2, 3. Again, carbon to carbon triple bonds, we call them alkynes. Okay? Sige. So, kanayin yung tandaan ha, pag may carbon to carbon single bond lang lahat, alkanes. Double bond, alkenes. Triple bonds, alkynes. If they form a ring, just include cyclo in the name. Cycloalkanes, cycloalkenes. Questions about these aliphatic hydrocarbons? Wala? So, oras na. Yes, Rosemary.
Ang karang aliphatic hydrocarbon, good ma'am. Ug ang alicyclic hydrocarbon, same lang na sila, ma'am.
Alicyclic?
Yes po. Hydrocarbon.
Yeah. Aliphatic and alicyclic parehas lang.
So, ano siya, ma'am? Alicyclic o katong aromatic, di ba na, ma'am?
The other one is, wait lang, I don't really use alicyclic here. Pero I use aromatic. The other one, aliphatic. Wait, let me recheck that alicyclic. If that belongs to the aromatic or the aliphatic. I think it's on the aliphatic hydrocarbon. Yeah, this one here. Aliphatic can also be called alicyclic. We seldom use the word alicyclic for this. The other one is called the aromatic. That's the next slide. And let's differentiate them. Okay, this one is the aromatic hydrocarbon. All of them have rings, and specifically the benzene rings and their derivatives. But how do we know or how do we differentiate aromatic hydrocarbon with that of the cycloalkene? Sa cycloalkane, okay lang. Okay? Again, I'll ask a question. Later, I'll ano that one sa quantum numbers. I'll answer that. Humano na lang ako ng aromatic hydrocarbons. Ang aromatic hydrocarbons kasi class, may benzene talaga yan sila and other derivatives of the benzene. So when you say benzene, this one is benzene ring. 6 na siya kabuk na carbon ha, and then naana siya ay double bonds. So 1, 2, and 3. So that is the benzene. Pero sometimes you have books and even in the internet, if you can see this structure, tas bilog ang sa gitna, that is still class benzene. So that's the indication na meron siyang double bonds. Now, how do we differentiate aromatic hydrocarbons from that of the cycloalkenes? Because remember, the cycloalkenes also form a ring and then meron din siyang presence ni double bond. We use class to differentiate the Haeckel's rule. So sa Haeckel's rule, meron tayong formula na ginagamit, 4n plus 2 equals pi electron. Again, 4n plus 2 equals pi electron. That is our formula for the aromatic hydrocarbons. Let's have the benzene first as the example. Let's use the Haeckel's rule to really confirm that it is an aromatic hydrocarbon. We will just write 4n. We will be looking for this n here. And then plus 2 equals pi electron. The pi electrons are the electrons in the double bond. So remember, we have 1 electron on the end. Let me change the color of my pen. 1 electron here, another electron at the end of the bond. That is also true for this. Sa double bond lang ha. So a total of 1, 2, 3, 4, 5, 6. We have a total of 6 pi electrons for the benzene. Tapos isosolve lang natin ito. So 4n, let's transpose 2 on the other side. So this becomes minus 2. 4n equals 4 divided 4 both sides. Wait, no, but ayan. So this is equal to 1. Now, how do you know? Sa Haeckel's rule, the substance is aromatic if N is equal to a positively charged or positive ang sign na whole number. Again, whole number ha, and then positive. So just like this one, this is equal to 1. This is positive and a whole number. So yes, benzene is an aromatic hydrocarbon. Okay? Let's have this one here. Gidraw na ko nga cycloalkene. Dito na ko siya draw. Sample 6 gihapon ang iyahang carbon. Bawat corner ana na siya carbon hamo ng 6. Tapos isa lang ka double bond. Ana. So ang question ani karon, is this an aromatic hydrocarbon or an aliphatic hydrocarbon? So just a cycloalkene. Ganun pa rin ang gagawin ninyo. 4n plus 2 equals pi electron pa rin. So 4n plus 2 equals how many pi electrons do we have here? 1, 2. Kasi isa lang. Isang bond lang yan. So 2 here. 4n equals 2 minus 2. 4n is equal to 0. So definitely this is equal to 0. So this is not counted as an aromatic compound. Dapat whole number from 1 hangtod pataas. Positive and whole number. So this is equal to 0, which means that this is not an aromatic hydrocarbon. Instead, this is just a cycloalkene, which is under the aliphatic hydrocarbons. Okay? questions about the difference between aromatic and aliphatic? Wala? So what about your question? Who was that again? Penelope, about the quantum numbers before we'll move on.
Sorry kay ma'am, kay different topic.
Okay lang. Sige, go.
Libog ramang good ma'am, kay lalang ba? Makabad.
Unsa na exam?
Maka-overthink, ma'am.
Sa
Ay,
exam na?
kuan man god. Ay, dili murag activity na mo sa lab last time, ma'am.
Okay. Tapos?
Tapos, kuan ma'am, naglibog ko ma'am kay wala pa naman di ba nimo gitudlo. So tapos na lecture man pagka senior high. So gamay na lang, murag nag YouTube na lang gud ma'am, nag Google na lang kay kato para makasabot balik ingana ma'am. Tapos sa YouTube o Google good ma'am, katong nag-search, di ba sa nickel man to siya ma'am. Tong gi-search nako ang principal number sa nickel ma'am.
Mm-hmm.
Ang nigawas good ma'am kay 3.
Tapos?
Kay kung anong man, so gitanaw na ako sa YouTube. Tapos mo to ma'am, ang explanation ma'am kay mag-base good daw sa last value sa electronic configuration good daw ma'am.
Oh, okay.
Which is Moto 3D8. Tapos mo dito 3 ang principal number kay sa last 3. Tapos Moto pag-check na mo sa lab.
Mali ka.
Na explanation ma'am nga sa to largest number good daw siya ma'am na 4. Tapos mo
sige.
to ma'am galibog lang ko. Apo ma'am. Moto to ko pa klaro ma'am.
Sige, let's clarify that. What is again the atomic number of nickel? I cannot memorize it. Can you look at your periodic table? Ano sa gani? Ako periodic table din. What is it?
28 ma'am.
28. So this one is the atomic number, walang charge. So ito pa rin yung gagawa natin ng electron configuration. So this is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, ilan na siya? 10, 20, kulang na lang og 8, 3d8. Okay, 3d8. If you say manggod, principal quantum number, this one manggod represents the highest energy level. Again, pag principal quantum number ang nire-represent niya, highest energy level being occupied by the electrons of nickel. And then, hindi siya actually magbe-base dito sa last. Let me clarify that ha. Hindi siya magbe-base dito sa last configuration. Instead, hanapin mo dyan saan yung pinakamalaki na configuration, and that will be the principal quantum number. So the correct answer here should be 4. Okay? Ito, yung pag-distribute ng electrons ni nickel, umabot na siya sa 4th energy shell. So if this is the nucleus of the nickel class, meron siyang first energy shell, second energy shell, third energy shell, and the fourth energy shell. 1, 2, 3, 4. Dito natin i-distribute class yung electrons niya. So sa first energy shell, makikita nyo, 2 electrons lang yan. So makakakita ka ng 2 electrons here on the first energy shell. However, on the second energy shell, you have here 2s2 and 2p6, 6 plus 2, 8 electrons. So you have 8 electrons here in the energy shell. Na second energy shell, I mean. While on the third energy shell, you have here 3s2, 3p6, and then the 3d8, so 16. So a total of 16 electrons here. While on the fourth energy shell, you can see 2 electrons. So since the p the principal quantum number represents the highest energy level being occupied by the electron, ang correct talaga na answer here is 4. Umabot na siya dito sa 4th energy shell when it comes to the distribution of the electrons in the energy shell, and you can confirm it to the period where nickel belongs. Diba sa periodic table, this one, this is the structure of the periodic table, right? So you have groups kung vertical, tama, vertical, like group 1A here, hydrogen, lithium, sodium, potassium, and so on. And then that's group 1 or family. And then Bemag, Kasser, Bara, that's group 2A here. Groups yan siya, pero ang period horizontal. So this is period 1 here, 2, 3, and 4. So if you look at nickel class, nickel is actually found here, kapantay ni potassium and ni calcium. And hindi lang maayos yung pagka-draw ko ng periodic table ha, pero nasa period number 4 yan siya. And that nickel is found, wait lang. Nickel is found here. So look at the periodic table. Isang period sila ni potassium and ni calcium, and nasa gitna siya. Nasa third to the last siya ng kanyang, ng itong part na ito, ng transition metal, nasa gitna. That's how you check the principal quantum number. Period number 4 siya. So 4 talaga ang answer, hindi 3. Anything else?
Okay. Thank you, ma'am. Kay
Okay.
nag-ask magud ko sa akong friends, ma'am. Tapos ningon lang sila nga, i-try na lang na open, try bito sa Google.
So that,
Kasi Google ang po dyan.
okay, so that is the reason why Google is good. It's very helpful. Everything is in there, but you have to actually assess the information you get there kung tama ba or mali. So ayaw ninyo tunla tanan. Tanan nga iingon sa Google, tanan nga iingon sa YouTube, or tanan na iingon ni Facebook, dili na to sila i-consider as tama tanan ha. So kailangan ta mag-double check. Let's check it with some other references kung ano talaga yung correct answer dyan. But the correct answer is 4. So pag maglibog mo class, pag mag-answer good mo og quantum numbers, and then na-confuse kayo kung tama ba talaga na 4 ang answer, balik kayo sa periodic table. Kasi the principal quantum number will be the period of that element. Kung asa siya na belong na period, mao na iyahang principal quantum number. Okay?
Thank you, ma'am.
Okay, sige. Anything else? Wala na. Wala na. So let us continue sa discussion natin with the organic chemistry. We have here the functional groups. In organic chemistry ha, our chemical substances are actually grouped together according to their functional groups. That will be their identity. The functional groups that are present in the structure will be the identity of the compound. And when you say functional group, it's an atom, or actually a group of atoms. Most of them are group of atoms arranged in a specific manner, in a particular way that will become responsible for the chemical and physical properties of the compound. So number 1, functional groups are used for the identification of the organic compounds, and number 2, the functional groups will be responsible for the physical and chemical properties of the organic compounds natin. So ito yung pag-aaralan natin class sa organic chemistry. Ganito sila karami. Actually, this is not yet complete, but ito yung mga examples of the functional groups that we need to learn for organic chemistry. I think the alkanes and the alkynes, tapos ko na siyang i-discuss. Ang tandaan nyo lang, silang tatlo ay carbon-to-carbon bonding, carbon and hydrogen only, but the difference is on the number of bonds. Pag alkanes, isang bond lang talaga yan siya, single bond. And if you cannot see the structure but you are given with the name, you can identify alkanes by their name ending, which is the ane. Pag ang name nag-end sa ane class, it's an alkane. So just like examples, methane, and then you have butane. That's another gas that we use as fuel, diba? Or for cooking. For cooking ang ating butane. And then we have the hexane. Yes, that is correct, Rosemary. The propane is also another one. Hexane, heptane, and even octane. So lahat na nag-end sa ane class is actually an alkane. So alkane, remember, hydrocarbon, carbon, and hydrogen lang yung kanyang component pero single bond. Okay, sige Charmaine. Noted. And then we have the alkenes. So in the structure of the alkenes, you can see the double bond between carbons. But nevertheless, hydrocarbon pa rin, hydrogen and carbon. Pero may double bond. So their names now will end with "in". So we have ethene, butene. So be careful with the pronunciation. Kay basig maggahi na to, tapos ang ato ding buti pasabot kay the butane. Example, butane. Tapos ang ato ang na-pronounce is butene. That's another chemical compound na for organic chemistry. So again, we call it butene, and then hexene and heptene. And yes, tama din yan siya, propene. Okay? And then pag may triple bond na, hydrocarbon pa rin, hydrogen and carbon, tapos may triple bond, alkyne na yung tawag sa kanya. And now, the name will end with "ine". Okay, ine ang ending ha. So we have here ethyne, butane, hexyne, and heptyne. Pwede din siya propyne. And the other substances depende sa number of carbons. By the way, itong mga meth, eth, but, that is actually the prefixes that we use to represent the number of carbons na present in the compound. We use meth if we only have one carbon. So as you can see, for our alkenes and alkynes, we don't have methane and methine. Kasi for you to have a double bond and a triple bond, you need two carbons. So ito, si alkane lang talaga class ang may methane. So the rest, magsa-start na sila sa F. F means dalawang carbons. So kung ang dalawang carbons na yan ay single bond, then that is called ethane. Pag double bond, ethene. Pag triple bond, ethyne. Okay? Questions so far for the three alkenes, alkenes, and alkynes? Okay, sige, daghan og brown out. Anyway, this one is being recorded so they can just review this anytime. I'll just convert this, upload this sa YouTube, and I'll be posting the link sa Schoology. Okay, and then fourth, we have also functional group that is called diene. Remember when you say di, it means dalawa. Meaning, and then in is for alkenes. Meaning you have two double bonds present in one compound. So just like the example on the screen, you have 4 carbons, tapos both ends of the molecule or the chemical formula have double bonds. So dalawang double bonds, diene ang tawag sa kanya, and that the naming will also end with diene. So instead of saying butene, butene kasi is referring to one double bond only. But when you say butadiene, that means meron na siyang dalawang double bond. That is also true for hexadiene. Dalawang double bonds na ang present in the chemical formula. So ito lahat class yung mga hydrocarbons natin in which their structure or their chemical formula only involves or only contain carbon and hydrogen. Pagdating kay alcohol pababa, hindi na sila purely hydrocarbons kasi meron na tayong additional element just like oxygen. So for the case of alcohols class, we will actually identify them kasi we will see OH in their structure. Again, we will see OH in the structure for the alcohol. Now, what is this R? R class is any functional group. Again, R here is any functional group. So when I say any functional group, the OH can be bonded with an alkane, or it can be an alkene. It can even be a ketone, an aldehyde, or other pa na functional groups. That's what we mean by R. But nevertheless, any functional group plus the OH will give us the alcohol. So how do we know them? If we cannot see the structure or the chemical formula, we can know them sa kanilang pangalan. Kasi their names will end with all. So if you can see the pattern of the naming class, methane. Dito tayo sa ethene. Ethane becomes ethene. Ethane becomes ethene in the presence of double bond. It will become ethyne if there is a triple bond. So, dalawang carbon lang yan. Now, syempre, hindi pwedeng dalawang carbon for the diene lang. Kasi kailangan mong, most likely, magsa-start sa 4 yan. Now, for the alcohols class, let's include ethanol here. So ethane, ethene, ethyne, if it becomes alcohol because you add the OH, it will become ethanol. So all alcohols end with all. We have methanol, butanol, hexanol, heptanol, and even octanol. Mga alcohols, yan sila lahat. And then, it's 11:55. So, hindi muna natin tapusin lahat. We will continue tomorrow. We will discuss ethers and all the other functional groups pa tomorrow. Magbibigay ako ng examples and then we will discuss the different structures na ginagamit natin, different types of formula na ginagamit natin for organic chemistry. And then after that, we will concentrate with, after this one, with the alkane and the cycloalkane. I hope we can finish all the functional groups, but I don't really think we can do that. So some parts of the organic chemistry will be continued in your biochemistry in your 2nd year. Questions before we'll end and we'll have our lunch? Wala na.